Hello students, so here in this class we are going to solve two more problems on beams, and we are going to find out what is the static and kinematic indeterminacy for beams. Okay, so let's see two problems. Before that, let's quickly see the formulation. Degree of static indeterminacy is equal to actual number of unknown reactions minus available equations of equilibrium minus number of internal hinges. Okay, and degree of kinematic indeterminacy or degree of freedom is equal to dk is equal to 3j minus r plus number of internal hinges. Okay, so these are the formulations. Now let's see the questions. Let's consider first problem. Let's consider this beam. So here it is a fixed beam. One end is fixed and other end you can see a roller support. Such type of roller is there. Okay, so this type of beam is there, and there are two internal hinges also. There are two internal hinges. So this is hinge, this is also hinge. Okay, now let us find out what is the degree of static indeterminacy. What is the degree of static indeterminacy? Before that, let us see how many unknown reactions are there. So for this particular support, you already know that there are three unknowns, right? Three unknowns are there. Now whenever such support is there, so in this case there are two reactions. Okay, there will be one moment and there will be one horizontal reaction. So two reactions are here and three are here. Okay, so degree of static indeterminacy is equal to number of unknowns, unknown reaction minus available equilibrium equations minus internal hinges, right? Minus internal hinges. I'm writing in shortcut internal hinges. So how many number of unknowns are there? 3 plus 2. Two unknowns are there. Minus available equilibrium equations are 3. Minus internal hinges. So there are 2 hinges. So minus 2. So degree of statical indeterminacy is 0. Means actually it is a determinate structure. Okay, it is a determinate beam. Okay, now let us see what will be a degree of kinematic indeterminacy. So do you remember the formula? What's the formula? Formula is 3j minus r plus number of internal hinges. Okay, number of internal hinges. Now how many joints are there? So j is equal to 1, 2, 3, 4. 4 joints. How many r are there? Means number of unknown reactions, they are 5. Number of internal hinges, let us consider internal hinges h, that is 2. Substitute in the formula. 3 into 4 minus 5 plus 2. So 12 minus 12 plus 2, 14 minus 5, 9. So degree of kinematic indeterminacy, degree of freedom is 9. Okay. So this is our answer for this particular beam. So hope you understood this question. Now let us consider a different example. Let us see a different example. So here let's consider this beam which is connected with two hinges. Okay, so this is a straight line. So here it is a hinge support. Hinge support is there, and then there is a internal hinge. Let me just okay. So here there is a internal hinge. Here is also internal hinge. Then there is a hinge support, and there is also one roller support. Okay, so just see this beam, it is with so many supports. So this is hinge support, roller support, and hinge. Okay, this is a roller support. Now let us find out what is the kinematic and static indeterminacy. So static indeterminacy, quickly you also solve with me. How many unknowns are there here? Hinge support means two unknowns. Okay, one vertical, one horizontal reaction. Two unknowns here. This is one unknown. Here it is again hinge support, two unknowns. So number of unknown reactions are 2 plus 2 plus 1 minus available equilibrium equations are 3 minus internal hinges. There are two internal hinges. So our answer is 2 plus 2 plus 1, 5. 5 minus 5. Again it is a determinate structure. Okay. So our answer is 0, means it is a determinate structure. So degree of statical indeterminacy is 0. This is our answer. Now let us find out what is degree of kinematic indeterminacy. So that is 3j minus r plus h. H is the internal number of internal hinges. Now tell me how many joints are there. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 5 joints are there. Reactions are, we already know, they are also 5. Then internal hinges are 2. Substitute 3 into 5 minus 5 plus 2. So 15 minus 5 plus 2. So our answer is 17 minus 5. That is dk. Kinematic indeterminacy is 12. Okay. So degree of freedom is 12 for this particular beam. So these two examples for a beam. Okay. So in this last in these three lectures, okay, we have considered different types of beams and what is the static and kinematic indeterminacy. How do we calculate static and kinematic indeterminacy for such beams? In next class, we are going to see what is the static and kinematic indeterminacy for the trusses. We are again going to see for the frames as well. Okay, students, so hope you have understood this class and thanks for listening to me. Thank you.